Okay, so here's what we've got right now. We still have the Thermodyne 24 volt single core PMA up on top of our 20-foot tower. We're still using the Thermodyne bracket, but what we did change was we removed the Thermodyne blades, the 11 blade hub that's got the green blades. We removed those and replaced them with the 11 blade Missouri Wind and Solar Raptors. And interesting coming in, I added a different view this time. So you'll see over here, you'll see my little mouse. That's the voltage coming directly off the PMA. And then down here, of course, is the amperage that we have coming off of that. Multiply the top times the bottom, gives you your wattage. Over here on the left, this is basically the state of Oklahoma. And this is a, the mesonet are, I think there's 77 to 100 wind state or weather stations. You can get anything you want to know about the state of Oklahoma from this website. And you can see right here we have 12 to 20 miles an hour winds coming in, and that's at basically 30 feet, 10 meters. And the colors will change. The higher the color you can see over here on the graph, 20 to 30 miles an hour is purple, and that's the reason that this right here is purple. So I live right at the top of this county that looks like an L. I live right at the top of that county, so we should see some winds coming in here in just a few minutes. And if you'll notice down here on the bottom, on the very bottom on the device, our Davis Vantage View, you'll notice that we've got 13-mile-an-hour winds right now. So what I've been noticing is that it looks like the Missouri Wind and Solar blades, just like when we did on the test before, they spin faster at lower wind speeds. And so what I wanted to do is just let this run for a minute. We're starting to see some decent winds come in. I'll tell you, the blades spin all the time on that particular PMA, but 8, 9, 10 volts is what we've been seeing, maybe 12, 13, 14. If it's below 10 miles an hour, the turbine is spinning, but there's no usable power on my 24-volt battery bank. So you can kind of see now, we've noticed that around 13, 14, 15 miles an hour, we start to actually make some power. We're on the positive side. So I'll just let this run for just a minute. There you go. So there's 8 miles an hour, and the blades are absolutely spinning. This meter over here on the right will shut off at 8 volts, so you'll probably see that fade out here in just a second. There it goes. It starts to fade now. That's because we're at 5 miles an hour on our wind. See if I can zoom in a little bit closer so that you can actually see the numbers of the wind speeds that are coming. It's a pretty unique tool that Oklahoma has. I don't know of any other state that has that. And years ago, I used to be a part of, I'd go out and work on those weather stations. So that was kind of fun to be able to participate in that. It was started by the University of Oklahoma and the Oklahoma Climatological Survey. While that's going, I'll just show you. You can get some pretty amazing data from it. You can get the mass convergence where the airflows are coming from. If it's neutral air or if it's actually moving, you can see that. You can get the gradients filled, so you can see the speeds that go right along with the numbers. So you can see, like right now, it's about 13 miles an hour, and we're at 11 at 20 feet, and this is testing it at 30. So there's a little bit of difference. Of course, the higher you go. What's a couple other things they have on here? Let's see. I think this one is just the maximum gust in the past hour, and you'll notice 1:40 p.m. February 1st, 2014. This thing automatically refreshes every 5 minutes, so it's a great tool to have. I use this thing often. This is my typical view. So you can see now, it's updated since we left. It's 1:30, and I'm showing 11-mile-an-hour winds about where we're at 30 feet. We'll give it just a minute or two to see if something happens. And I know that we had the the Thermodyne green blades on. In the last test we did, the winds were screaming fast. They were we had 30, 35 mile an hour winds. And you saw the power output that we received. So I thought this would be, well, this isn't an apples for apples test. From what I've noticed, it looks like we'll start making power. If I can get 13 to 20 mile an hour winds, I believe with the Missouri Wind and Solar Raptor blades on the Thermodyne 24 volt PMA, we'll probably make as much power as we did using the same PMA with a whole different set of blades. I just think this is an interesting test to be able to see really at what speed, because we have some pretty consistent breezy winds right now at 8, 9, 10 miles an hour. At 11 and 12 you can see we're just right at the edge of hitting that 24 volt mark, but no current. It's not real gusty, it's very steady winds. I think if we'll hit that 13, consistently, we'll see. There you go, 24, above 24 volts now. And if you look up on the map, it's updated again. It now says 140. It's showing 13 to 20 mile an hour winds coming in. So that particular weather station is about 6 miles directly to the east of where I live. So, and that's at 30 feet. So we can expect, just from my experiences, we can expect somewhere between 10 and probably 15 miles an hour pretty consistently. We'll probably gust up to 20 a little bit, but that's what I think we'll probably have. And then behind that, if you look over to, to the northwest, there's 13 to 19 mile an hour winds right behind that. But I think the key to this is the thing's out there spinning like crazy, but we don't know, what kind of power that is, or we do know what kind of power that is. But I guess if you didn't have the meter, you would just be thinking, man, that thing's spinning like crazy, and we're making all kinds of electricity. But really, we're not. It's moving, but until it hits a certain speed, you're not making any power. And that's what I want to know. What is that wind speed with different combinations? What's the most efficient? What is the best combination of PMA and blade set for my area with my wind speeds, and then other people can use that knowledge and kind of make their own determination. So you can see now it says it just updated again. It's 145. It says 15 to 21 mile an hour winds, just a little bit over to the east of us. So we'll give it a half a second because I bet we're kind of in the calm. We might be able to go over and look at that wind divergence report. There you go. So if you'll see right here, see that divergence? We are right on the edge of that. That's that calmness that we have right now. But that'll change quick enough. And I realize this is really slow, and you know the numbers are crazy low, but I think it's a great opportunity to kind of watch and see what is the actual power production start point, right? The 24 volts. When do we start? When we show any amperage on the bottom, when we get 0.1, then you know we're kind of in the positive there. What is that? What is that point? And we're teetering on the edge of that right now. So that's the reason this is long and boring, but it really tells us good information. Not how fast the blades spin up, but with this combination of the Missouri Wind and Solar 11 blade Raptors on the Missouri Wind and Solar hub, and using the Thermodyne 24 volt single core PMA, where's it at? So it looks like 14 miles an hour was the 15. Let's see what happens. So I think I saw like 2 amps at 15 miles an hour. Remember, there's a little bit of a lag time between what you see on the mile per hour in the circle right here and the actual results that show over here. It can fluctuate back and forth, right? This could be ahead a little bit. This could be a really high number. So you kind of have to watch. And when you get the highest output over here, you have to notice and say, it may come 15 miles an hour just a second before you get the results here, or this may say high before you get the actual results over on that. It can go either way. You have to do some analysis and just watch it closely. So it looks like it's about 13 miles an hour. According to my weather station, we start to make positive energy above 24 volts that's charging the battery. So it may look good that with this combination, below 13 miles an hour does nothing for me. Unless someone else wants to counter that and give me some other feedback. Yeah, still at 145. So at 13 miles an hour, we hit 24. It went to 12, and we went below. So I think 13 miles an hour with this combination is going to be about the magic number for me. So now that I've noticed that, let's just watch it for a half second and see what happens. We're looking for the magic 13 to be positive. There you go. 15, we got 2. 16, I see. Maybe it was 16 miles an hour. We got about 2 amps. And that's exactly what we want to watch. We want to watch it very slowly and consistently come up. So for me, in Oklahoma, if I average 15.3 miles an hour, then I could probably bet throughout the year that number comes from the government. So we know that if it's 15 miles an hour and I make 2 amps on this test, I would average 50 watts would be my average power a year out of this device. There's 16 making 4, 19. That may have been the 19 making 4, 18, 19 miles an hour. So I think we can, pretty conclusively say that of the combinations so far, the Missouri Wind and Solar Raptor blades are probably going to be, I think we've seen so far in lower winds, they are making better power. We should have 15, I think it's 15 or 20 to 30 mile an hour winds come in this evening, so I'll try to run another video then. Let's see if we can get, there we go, there's 12. It's up and down right now. Okay, I'll give it about another 30 seconds. We'll see what happens. I'm going to shut it off. Yeah, I'm looking at there we go. We're 155 and it's showing 14 to 20, just over to the west or to the east of us. Yeah, that divergent line is still there. It's of 135. That hasn't changed, so. See, it's kind of interesting. You can see there's the big giant wind farms run from Texas up through Oklahoma through this area all the way up into Kansas, and you can tell the numbers are usually pretty high over here. It's just about maybe 10 miles over to the west of where I'm at. So between Norman, which is over to my east, and Minka, which is over here where the wind farms really kind of start. At 30 feet, I'm somewhere in between there at 14 feet. So my 20-foot tower doing, 9, 10, 11, 12 miles an hour is probably pretty accurate. So 50 feet would probably be in my best interest. Okay, I'm going to shut it off. I think this was a pretty good example. When the higher winds come in, we'll run another video to see what it is. We have a consistent number, above 13. I think is really where we want to be, above 13. So for right now, though, it looks like we were able to kind of prove out with Missouri Wind and Solar Raptor blades running the Thermodyne 24 volt PMA 13 miles an hour is what we need to have. And there you go, 13 miles an hour, and we were at 24. We went to 12 and we dropped down below 24. So that's going to be the kicker. Okay, good stuff. Thanks, folks.